Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. We're working on this opening cinematic scripted event, right? So Tashio's on the floor there, Mage comes up and rescues him essentially and carries him out. So we don't need this scene, we don't want this scene on autumn grass here, we want it in the volcano realm, in the volcano biome. So yesterday at like 4 in the morning, I spent making this lava flowing animation here. So we're gonna add a whole scene of just this soot, but then also add like a stream of lava, so Mage can lift Tashio up above the lava and carry him out and kind of rescue him. So what that involves is, exporting all the tiles, grouping them into animatables, and then the way our game is set up is we kind of draw, the game will recognize we code in the first frame of an animatable, and if while we're inserting it into our tile set, if it's the first frame of an animatable, it goes ahead and creates an animatable that we define of maybe 4, maybe 5 frames, what speed it's maybe at, and then it inserts it into a .animatables table that is updated over time so that we have this illusion of movement. One thing to consider is that the flowing lava itself needs to be a collidable map object so that you can't just walk through it. So we'll be doing that as well, so we might have to split up a certain amount of these tiles, but any time we're doing an animatable like this, we're gonna save the A-sprite file so that we can modify and re-export as needed if we want to do a tweak. So what's cool about A-sprite too is you can come in here and say view a tiled mode, and it kind of loops it for you so that you can view it. It's like that's the kind of flowing lava that I did from yesterday. So we'll see how it looks in game. It's always a little tough to know if it's going to work as is, but once we put it in game, we'll see if we like it or if we want to tweak it. So let's get going here. I think the first thing we need to do is kind of export individual animatables, right? So like there's the left side, a middle side, and a right side of the lava. So we need to export all those as their own atlas so that we can import them into our master sheet and then start drawing them. Okay, so, and you know what? I think the move might be, I think it might be easier to just export this whole thing as one atlas and then chop it up from there. That might be the move. Okay, so if we export a lava animation PNG as an atlas, let's see what it looks like. Okay, cool. So it splits up all 5 frames of our lava here, and we can pull this into A-sprite and chop it up as needed. So the middle lava one's the only one that needs to be segmented onto the collidable map object row, and then the rest of these can be down where the animatables are, because these are all animatables, which right now, like flowers, I'm putting down at the bottom of our master atlas. So let's just edit our master atlas and try to add those. Yeah, so far these are all the sprites in our game. It's kind of all over the place because I'm kind of starting from the corners. but we can build out the animatables here. So I can pull in our lava anim PNG here. Okay, so I think the move is if there's 5 frames and we need both left and right, that's 10. So there's 3, there's 5, there's 3, there's 5. Yeah, we'll do the right sides first and then go to the left side. So let's do this one at a time here. Yeah, so like even though it's not much that's being animated, it helps blend it, right? So it doesn't just look like it's a square on square. It just helps give it a little more uniqueness. Okay. So now we need to sandwich them all together as all the rights. I can't imagine doing this without a sprite or tiled, man. This would be impossible. So these look to be the sprites we need in order: frame 1, frame 2, frame 3, frame 4, frame 5 for the right side of the lava. So now we'll do the left. Same deal, we'll work our way backwards. And if we do need to edit this because it doesn't look good in game, we would just have to, yeah, we'd have to redo this, which kind of sucks, but at least a sprite gives us the way to preview it, you know. I was pretty happy with this last night, but also that was like 4 in the morning. So might want to change it. You know, it looks kind of strange there, all separated out at the bottom, but we've seen the animation when it works and it looks okay. So we'll see how it looks in game. Now our lava sprites just need to go on a very specific level of our game so that we can't just walk over it. You know, we could have it where you can get spit into the lava and it's not really a collidable level, but you would just kind of get incinerated, but we're not doing that now, at least for the cinematic. You aren't able to get to the lava biome in the demo, so this is just for the opening cinematic, really. But we can take our lava and we can put it anywhere that has our these 6 rows of red are our collidable tile map layers. I don't know, I'm kind of thinking we'd just put it up here. Okay, as long as that lines up, yeah, looks like it. Cool. So if anytime any of the tile IDs in this row are drawn, our player cannot walk through them. And then we'll have to define some enums for our anim starters. Because basically what happens in our game is we declare what the first frame of an animatable is. So a tile ID of, let's just say this is 1000. Since it's the first frame of a 5-frame animatable, our map downloader goes in there and says, oh, this is a tile ID of something that's declared as an animatable. So let's go ahead and grab all the next animatables for it and make a animatable object and insert it into the global table so that we know how to render it and update it over time, because all of our other tiles are just inserted into the ground level, and then we just render whatever's in the ground level. But an animatable needs to cycle through something like 5 different frames. So the speed at which it does that and which tiles it's cycling through is all made possible through our animatable class. And then same thing with this, except also the tile IDs are collidable, so our player should not be able to walk over it. And you know what? That might give us issues. Now that I think about it, it might give us issues when Mage tries to bring Tashio over, because we're running collision detection on collidable map objects, so we might need to move that. I don't exactly know though. And FYI, I was up, till 5 last night doing work and stuff, so I had about 3 hours of sleep, so my energy levels are shot. So I'll probably only be streaming another like 40 minutes and then pass out. We'll see. We'll see how far we can get. It'd be nice if we can get all the soot working, because I also want to add the particle system for the lava biome into the cinematic there, because it has falling soot and raising lava particles like our title screen, so we'll have to add that as well. But now that we've got that, we can save this. We can export it as a master sheet PNG. Now we can draw with tiled. So let's take a look first. Let's take a look how we're doing these animatables. So we have an animatables table for every scene, and we come in here and we have a insert animation update. Okay. I don't like this. This is kind of gross. But basically we define an enum, which is the starting frame of an animatable. And then we basically say this 3D array here is which tile of 80 the tile ID goes in for every scene. So into the animatables global table for the scene, we're inserting a function itself, and the function call that we're inserting is the insert anim that takes in whatever row we're at, whatever call we're at, and whatever dot frame we're at. So I think this kind of looks like it's hard coded to a 4-frame thing. Because how does it know? Actually, no, we'd have to look at this insert anim. We have this other thing defined here. Okay. See, this is kind of this anim spitter class we had takes in a starting and ending quad. So we have to manually declare which tile ID is the ending quad for the anim spitter. A little convoluted, but I didn't know how to do this, so this is all handcrafted. But this tells us how to do it, right? We need this starter. So we'll call this lava left edge anim starter. And then right edge starter. And then lava flow anim starter. Okay, and then we have to declare these as a tile ID for the very first one. So let's go snag that real quick. We have a Python script that goes and puts numbers next to them. But for now, we have one exported, tiles.numbered. Yeah, we can see the tile IDs here, so we can just snag it from here. We need the tile ID from our master sheet here. So right here, master sheet. Okay, so it's, they were what, 4 or 5 frames? Come on, man, why is this not zooming in for me? Okay, 5 frames would be the left starter. So there's 1, 2, 3, 4, 5. It looks like it is 1022. Oh, no, 1002. Seven, 6, 5, 4, 3, 2. 1, 2, 3, 4, 5. No, it'd be 1, 2, 3, 4, 5. So 1003 would be the left edge starter. And then the right edge starter is 5 pixels to the left of that. So there's another 1, 2, 3, 4, 5, 98. Okay, so that's 98 to 99, 100, 1, 2, and then 3 would be the start. Yeah, that looks right. Now we need the lava itself, which is to the right of, all of our collidable map declarations here. Yep, it's just at the top of those, so we should be able to look at those. Man, here it is. Should be 117 and 5 over. Okay, so we declared our enums for the starter animatables. Now we need a global anim spitter for it. This is definitely not the best way to do this. It's like duct taped together. We have lava, left edge, anim starter, and it takes an ending tile. So the left edge is gonna end at 5 higher than we define it, so 103 to 4 to 5 to 6 to 7 to 1007. Then we can give it a speed. We'll just put this 0.5 for now. And then this is lava left edge, right? Okay, and then the right edge starts at 998, so it goes from 98 to 99012,002. Okay. Then we need our lava flow. Okay, and then we start on 117, and it's 5, so it goes from 1, 2, 3, 4, 5, 121 should be where it ends. Okay, so there's our anim spitters. Let's just take a look at what anim spitter is, just to see. It's just a starting quad and ending quad. And then it's also a timer threshold and then a frame. And the frame is assigned to the starting quad. It's got a timer, so all the anim spitter does is it updates a timer. If the timer is bigger than whatever threshold we defined, let's advance our frame. And then it should loop. If it loops here, we could do a loop with the modulo, but we just say if our frame is the ending quad frame, we're going to set our frame to the starting quad so that it loops back around. Otherwise, if it's not at the ending frame, we're just going to increment our frame. So anim spitter's super easy. But on top of that, we have, where do we use the anim spitters? We do it right here. We say, we make these. So where do we do something like adding in water? We do it here. This, I don't like how we do this, but we do this manually where we say, this is in our data downloader. So once we save the tile IDs from tiled, we're going to check if, before we insert it, if the ID is going to match whatever starter for the lava left edge anim starter. And if so, we're going to insert into our animatables table a function. And like we insert but don't invoke this function. We just put this function in a table of animatables. And then we cycle through our animatables and run the function so that it effectively updates the frame for the animatables that are in the frame there. That are in the, whatever, in the current scene. So in an anim spitter, it also takes in a starting frame. And the starting frame is just like whatever it's the first, like right there we've got flowers, water. So this is the anim spitter object dot frame. Okay. Because insert anim is different than anim spitter, so we'll take a look at what that is too in a sec. So lava left edge dot frame. Not starter, just left edge dot frame. So let's take a look at what insert anim does. Man, yeah, this is weird. So insert anim takes in a map row and a map column. It has an update function where we update the anim spitter. And then we cycle through our animatables. And if we're on the last row, what are we doing here? Then we're going to invoke the actual function that is in the animatables table. So we're cycling through the animatables. I don't know why we have this. This is doing nothing at this moment. But basically we cycle through the number of things that are in our animatables table. So if we have only 4 animatables in our whole scene, there's only going to be 4 animatable functions inside the .animatables. And we say let's do a loop of 4, cycle through all the animatables, and just execute the actual function. Actually invoke the function of insert anim that we put in here. And it's a little confusing because insert anim is the function here, and insert animation is the class that we're doing right here. So it's a little confusing. But basically all the insert anim is doing is saying we're going to take, I don't even know, like the animatable that we pass insert anim, we're going to insert into the current map.tiles row column ID, which is what gets rendered on the floor. So we're setting the ID to be the frame of the animatable that we're updating here in the insert anim. Actually in the insert animation. So this dot frame, that dot frame of our anim spitter is what's actually getting inserted into the row that's being rendered on the floor, for example. So it is weird. It is weird, but it works. But you know, I don't like this where we have to update all of our anim spitters every single frame, even if there's no animatable object in the current scene. So I don't think I like that about it, but it's what we've got at the moment. So yeah, basically these are kind of just like perpetual throughout the game. These anim spitters are kind of running in the background, updating whatever frame that, if there were a lava right edge starting tile in the tile sheet that we draw, it would go ahead and update that frame based on the time that we gave it. So we also need lava flow. So those should be our 3 animatables we're trying to insert. And yeah, we basically just, all we do is make sure we update that so we get the right frame. And then we invoke the animatable function that we inserted, and we did that right here. Right here. So if the starting tile, this is how we get it so that in tiled, we only have to draw the first frame of an animatable, and then it knows, okay, well, here was an animation starter. So let's go into our animation table and insert this function that will put in the frame of a constantly updating frame value so that it will update over time and render on the floor. So we need to do this for the other right edge anim starter. As well as lava flow. Okay. Yeah, I don't really like this overall, how we do this. But it's part of our data downloader, so when we go to insert it, you know, we have to remember what this insert anim is, because we need to know the range of tiles to cycle our animatables through. So we store it as a function in the animatable table, and we keep track of the current frame, and then we just update the frame through the range we define. And we define that range here. Right here in our map declarations. Why is everything... Oops. Oh, we need a not end here. There we go. Okay. And then we do this. Nope. I'm trying to find where we actually define the endpoint for those animations. Right here. We define them in global anim spitters in our map declarations, which is kind of weird, but you know, we need them global because any scene needs to be able to access them, so I guess it makes sense. Okay. So I think we might be okay to test doing this stuff. It should be that simple. In the grand scheme of things, you know, we're trying to insert animated objects wherever we draw it. So there's a bit of manual process to it, but I'm hoping that it actually works. Let's get the other. We need the soot sprites. Which right now we only have this. So we have like 2. I can put these somewhere. I don't know where. It doesn't really matter. We just need specific frames for them to live at. You know, just so they're not always needing to be repeated, we can kind of mix it up just a little bit. Okay. So for now, we'll do that. Let us export as a master sheet, and then we'll try to draw it using our tiled application here. So, all right, we pull open tiled. So our cinematic here is all the way in the other world, and it's right here at the bottom. So let's try to add our soot. There we go. First of all, I drew this in the wrong layer. We want to make sure we're on the ground level here. Okay. Let's try that again. So here's that soot. And then I'll just sprinkle in this alternating art so that it's not so repetitive on the art there, or for the tiles. Okay, and then we need to add our lava flow. So what we do, all we do is draw the first frame of the lava flow. So we have a left frame here, so we're going to draw a left lava chasm here, and then a right lava chasm, which should be this one. As long as we're drawing that first frame of it, our game will know, oh, that's an animatable. Let's go ahead and insert the resulting frame from our anim spitter that's getting updated every second. And then we need to insert the lava, and here's where I think it'll actually mess up. So we insert just the first animation for the lava, but since this is in the collidable map table, the collidable map row, I think Tashio will probably get stuck here. But ideally, Tashio's over here knocked out, right? And Prentice comes over and uses magic and lifts him up and floats him over. So we're gonna see what it looks like. Let's see. So all we've got to do is export this as a global map, and we'll see. We're looking for the animation to be working on all of them. That would be big. Oh my god, look at it! Yo! He lifts him up and he pulls him over. Oh, that's epic. The freaking animatables worked. Wow, that looked awesome. So we should add the lava particle system. You know, like I guess one thing I'm thinking of is it kind of looks like a lava fall, like a waterfall of lava, instead of just like a stream of lava. So maybe if we had some kind of structure to make it look like it's part of the ground instead of like a waterfall, that might be nice. But that was really cool. I think the only thing else we'd want is to scoot over Tashio to the right just a bit. Maybe scoot them both up and scoot Tashio over to the right. So we can do that here in our opening cinematic. We're starting him at tile 5. Let's start him at tile 3, so 2 tiles up. Same with our mage. We have an NPC inserted here, so that's actually in our map declarations. And we do that right here. Yeah, we put him here at a tile size times 6, so let's lift him up two tiles as well and see. We will also want to put Tashio over to the right, like 1 tile or so. What up, Loki? How's it going? Yeah, we want to put him over to the right more, and let's see how that looks. So we run our opening cinematic. Oh! Yeah, we messed up his Y position. Tile size times... Is there any time... Oh, see, look, we did this. Well... Yeah, we have this right here. Times 5. Now this is a times 3. We should not magic number this. We should do this proper. That probably should fix it. Yo, how's it going, Loki? Oh, that looks awesome. That looks so good. Okay. I like it. I like it. I still want to scoot Tashio over to the right one. He didn't look like he scooted, did he? So his X. Oh, nice. Yeah, dude, that was looking fun the other day. Sweet. Sweet, sweet, sweet. You know, the lava could maybe afford to go a bit faster. So maybe in our lava flow, is it the anim spitter that we define the rate? Yeah, we define a rate of 0.5. Let's try to do faster 0.25. We'll see if that looks okay. Oof. Oh, that screws it up. That screws up our sides because we need it for here also. So we'll just do that. That might be too fast, but... Oh, okay. Well, hey, that's good. You fix it. Do you use Git for version control or anything? I think it's a bit too fast. It should be more bubbly, I think. I do want to also do... I want to do little bubbles, little lava bubble pops. That way we can kind of litter these bubble pops of lava on any lava biome level, just as a extra little flair. Because it'd be nice if there's some little bubbles popping, just as a sort of world builder thing. Okay, nice. Yeah, I really recommend that. Exactly for what you're talking about. But I'm glad you got it working again. I know that like there's nothing more disheartening than like working so hard to figure something out and then losing it and then having to do it again. That really sucks. You know, I think this reads as lava. You know, I'm not good at pixel art, so it doesn't like I also made it at like 4 a.m. last night. But I think it reads. I think I'm okay with it for now. Let's add in our lava system. So let's do this where we have a lava system. Yeah, so we can require our lava system from our dependencies. So let's see. Oh no, we require it as a global, yeah? Yeah, require lava system. So we need to declare, all we do is declare a lava system in our opening cinematic here. We'll say the self lava system gets an instantiation. Then we say lava system gets updated. And then we need to render our lava system, and then we should have it. It should be that simple. We have to get the right render order layer though, so it'll be after we render our player and everything. Oh, okay. Gotcha. Yep. Okay. Nice. See, now there's this like lava spawning, like the lava bubbles spawning, and then some soot falling, like a really subtle kind of effect. I mean, I don't know. It looked a little too intense, you know, so maybe we tweak that a bit, but oh, it looks cool, dude. Yeah, I think the reds are just a little too distracting. Just by a bit though. They're just too bright. If they were like half as transparent, let's try that. Yeah, so we've got a bubbles and we've got a soot. So we just want our bubbles to have a starting brightness. Oh wow, we really screwed this up. 0 of 02555. Let's start them at 200 opacity and fade to 0. Nice. Cool. As long as it's readable as lava, right? Like, as long as, like, I showed my girlfriend and she was like, ooh, lava. So I was like, yes. Like the fact that you aren't like, oh, it's like tie-dye. Nice. Yeah, I'm just imagining this with like some spooky music. It'll be cool. So this is like the first thing you'll see in game after the title screen when you start a new game. So it's kind of a big deal. Nice. Yeah, I don't know. The particles are still, I think there's too many red lava soot particles. So lava emission rate is set to what? 20. Let's set it to 10. Nice, that's looking good. And, you know, he looks like he's in a lava biome, you know, just with all the soot and stuff. You know, I think I want... What I don't like is that the background here just looks so flat, like, because it's all the same. It's just, like, all the same tone. It looks almost like a wall, and that this is, like, a waterfall of lava. That's just what I don't like about it. So if we had something to kind of... I don't know what would help this, because it's like... It should just look like top down. And it looks like we're kind of looking straight on at something. I'll have to think about how I can pull that off. But this is huge. So this is the first step of the opening cinematic. What happens after this is he drags you off screen, it fades to black. It fades from black to the insides of Mage's castle. And he'll walk over to you, narrow the top of the lava stream. We could. I'm thinking, because it's like since it's a top down, it's a top down. So like the dimension that would be accurate if we're looking at it like at an angle, but it's supposed to be top down. So something like that I think would look weird with the rest of the game. But there might be a way we could finesse it. Yeah, the other thing we could do is maybe add a curve in the lava, so it's not just a pipe of lava falling down like that. But I don't know. Honestly, I'm not too worried about this. Like, yeah, maybe we can just find some things, like some other assets for lava. Like maybe we have like some skull and bones or something littered like we do in the desert. We can try that, because we've already got those made, so we can kind of just use some skull and bones like right here. Oh, like these rocks and these skull and bones. I like these. Yeah, and you know what we can do? We can just copy these as a top level tile asset. So yeah, what we can do is use these as a top level tile asset and draw them wherever we need them. So let's do that. Oh, shoot. Yeah, we probably should have had these. I mean, I didn't think there was going to be skull and bones in any other biome, but the mountain, actually, it makes sense to be in the dungeons, it makes sense to be in the mountains, it makes sense to be in the lava, so I'm glad we're doing it. Okay, so there's our above ground level assets here. So let's just copy and place them. Perfect. So we save this to our master sheet. We can reload tiled. And now if we go to the above ground level layer, we should be able to just draw some of these. Oops. Always do that. Okay. Above ground level, let's just draw some bones and stuff. Just a couple, you know. And some rocks. Yeah. Yeah. Okay, export global map. And let's give it a shot. Wow, that looks gnarly. That looks gnarly. I think I don't like the bones on the same exact height as Tashio. That's just too distracting. But we can add them down there and maybe get rid of these. Okay, let's see. Okay, we're going to load our cinematic. Actually, let's do it from the title screen. Let's just see, because we should trigger a chasm death here. We have a game over. We can go to the title screen. We can start a game. We go to meditate. We wake up. We can load the cinematic. Oh, that's looking so sick. Oh, dude, that's looking so freaking cool. Yes, yes, yes. I love it. And then we'll do a fade to black, and then we'll open up in the castle. Cool. All right. I'm running on a couple hours of sleep, so I'm gonna call it a night here. Let's just take a look at our git diff. Oh my goodness. All we did was, actually, what was that? Visible true. Oh. Let's fix that. I didn't realize that if you had this turned off, it actually changes what global map gets exported. So we'll leave all the layers on so that we don't have that in our git diff. And then we basically just added a different master sheet with a couple of different animatables, changed lava emission rate, fixed a bug for our lava bubbles opacity, added 3 anim spitters for our lava animations. We changed the locations of our characters for our opening cinematic. Yeah, looks pretty good. I'm really happy with it. So we'll say added lava biome to opening cinematic. That's looking so good. And we'll get push. Sweet, sweet. Let's run our credits here and we will find someone to raid out to. Yo, thanks for watching, everyone. I'll be back tomorrow. We'll be working on probably the castle, because we're still in the mode of let's do all the hard stuff first, and the cinematics and triggering all that dialogue and exposition is the next up on the difficult list for the demo. So we'll trigger the opening cinematic to the castle to the opening dialogue. Then we'll probably make a little library for a self-tutorial area, and then we'll work on dungeon design And then we'll work on inventory system and probably implementation of music and sound effects. So that's what's coming up. Thanks for watching. Oh, here, we'll find someone to raid out to. We'll raid out here. Let's see. We've got Jed. Yeah, we'll hit up Brightside. I know he's working on his game. Thanks for watching, everyone. I'll be back tomorrow. Hope you all have a great night.
Yo, Jake.
Yeah.
Are you at your computer? Quick for me.
Yeah.
All right. You have